Hello and welcome to today's ACM SIGSOFT webinar. This webcast is part of ACM SIGSOFT's commitment to provide value to its current and future members. The ACM SIGSOFT webinar series features speakers from the International Conference on Software Engineering, as well as select keynote speakers and distinguished paper authors. I'm Will Trace, Lockheed Martin Fellow Emeritus, past chair of ACM SIGSOFT and current software SIGSOFT Special Projects Liaison. It's my pleasure today to welcome you. Today's presentation, actually, I have to give you some background for those of you joining us for the first time. I'd like to quickly mention a few housekeeping items shown in the slide in front of you. That should have been there. Yes. First, the slides will advance automatically throughout the event. On the bottom panel, you will find a number of additional widgets and resources. If you're experiencing problems with the slides or audio, and some of you always will, press the F5 key in Windows, Command-R in Mac, or refresh your browser on mobile devices, or you can close and rewatch the presentation. To control volume, adjust the master volume on your computer. If you have questions during the webinar, please type them into the Q&A box at any time during the webinar and click the Submit button. At the end of the presentation, we'll have time to respond to questions. This session is being recorded and will be archived. You will receive an automatic email notification when it becomes available. So as I was saying, today's presentation is Succeeding with Large-Scale Software Development Measurement Programs by Miroslaw and Wilhelm. Miroslaw is a professor at the Department of Computer Science and Engineering at the University of Gothenburg, Sweden. He has published extensively on software metrics, model-driven software development, empirical software engineering, and cooperates with Ericsson, Volvo, and other telecom companies and car manufacturers. Will Medding has worked as quality manager for over 10 years at Ericsson and previously in similar positions at Volvo buses and Volvo cars. He is currently working as a management program leader at Ericsson, leading a team that manages measurement systems for various parts of the organization. Miroslaw and Will, without further ado, please take it away.
Thank you, Will. Thank you so much. Welcome, everyone. So we will talk about the journey we did on the measurement programs, how we succeeded, and give you a few tips how to do it without so much pain as we suffered. So, I'm a professor in software engineering. I've been working together with my colleague Wilhelm for over 12 years in areas of software measurement. We wrote a number of publications and recently published a book that, of course, you can take a look at later on. So, how is it that we succeed? Well, we succeed quite well because we have this model of working together as industry as a lab, where we have a number of companies collaborating with us, where I, as a researcher, spend time at the company's premises, go over to Wilhelm and work with him on software measurements, collecting data, where I have Wilhelm and friends from industry coming over to us and giving seminars, providing us with the data, with problems, and when we together set up a collaboration so that we can take one result from one company and move it over to the next company without having too much trouble and problems. So, what do we do? What we do is something that we call measurement systems, and they could look in different ways. They could be in terms of, they could look like Excel files or web pages, where we have a number of different measurements, and when we have different views on the measurement. They could look like Microsoft Windows gadgets or Mac OS widgets, apps on mobile phones, or they could look like information radiators, big screens standing in landscape of companies showing the current status of software development. But of course, this is one way of looking at that, and behind this there is a whole bunch of things that one needs to do. So when we talk about measurement systems, we talk about much more. We talk about things like artificial intelligence-based measurement. Measurement where we don't really have to measure ourselves, where we have AI components and machine learning to suggest new metrics to provide new ideas and insights. We have simulations of outcome before we actually do something. So we have built models that could predict the number of defects in products, number of mistakes or number of releases, and that we could play around by putting in different parameters. And of course, for theory building, we also focus on metrology when we create new types of measurements and provide that to companies and to the community as part of something what is called measurement reference etalons. You can think about this something like a measurement of a kilogram. And if we look at the evolution of software measurement in general, that the topic is of course not new. It started around 1960s when people started to measure the size of Fortran and COBOL programs. But the first book was introduced in 1976 by Tom Gill, which introduced a number of different kind of metrics. In 1977, the metrics of Hallstatt complexity popped up. In 78, we had the Beams quality model that is still used today. In the end of 1980s, we had the Go question metric models and the ISO 9126, which are still used today in many companies. And around the beginning of 2000, the new models of ISO 15939 specifying how to measure software and how to design measurement programs have been designed. And those things have led us to our work. When we started our collaboration, we started the collaboration with looking at something that was a problem at the very beginning, automation and predictions. The industrial problem, the industrial challenge that we tried to solve was how to predict number of defects coming into software projects. And we had one company, one university. We started with one manual measurement system. After a while, we worked a bit more on automation and large-scale measurement systems, which led us to discovering problems of information quality, which Wilhelm will talk about a bit later on. We started working on more advanced measurements of visualization of code stability in large code bases, products that have millions of lines of code. And already over there, around 2010, we started working with more than one company. We were 4 companies, 2 universities, and already there we had over 4,000 measurement systems. And having that many measurement systems has led us to understanding that we need to have a mechanism of maintaining them, and that's why we're working a lot with self-healing of measurement systems and understanding new metrics like release readiness, and Wilhelm will introduce those concepts in a moment. After that, in the next few years, we work quite a lot with expanding the number of different areas which we work with. We work with the higher level metrics, key performance indicators. We started to collect and catalog metrics that were used in modern companies, and we collected over 1,000 metrics already in 2016. And at the very same time, the number of measurement systems that we have developed has grown to over 40,000, which led us to a number of different challenges. Of course, trying to understand how to use that to provide insight into software products, so software analytics. And we also understood that having this large amount of data enables us to use artificial intelligence and machine learning to actually find new metrics and to manage measurement systems. And now I'll give a word to Wilhelm to show you a bit more about that.
Okay, so let us take an example from real life. So back in the day, we're talking about 2004, 2006, I was working as quality manager in software development projects. We've been part of the project management team, and the size of the projects, there were around 300 to 400 software developers. And everybody knew that Meding loves his metrics. So I had the privilege of compiling everything that had to do with measures in the project. after some time, this grew to be a problem since I had too many measures to handle. And I couldn't get my colleagues in the project management team to understand this because I had no tool to conceptualize, to materialize this word many. So 2006, I started a cooperation with Professor Staron, and one of the first things he did was to introduce me to the ISO IEEE standard of 15939. One of the things that I described there is the measurement information model, which simply put answers the question, what does a measurement system look like? So understanding that, what I did in the middle of ending one project and starting up the next project was that as I was collecting measures, I put them, as you can see here, and those who have read the standard will recognize the different areas, the entities, the base measures, derived measures, and indicators. So when I came halfway, I printed this out into A0, which means 1 meter by 2 meters. I would guess it's 3 by 7 feet. And I took this huge piece of paper and went around to my colleagues, putting this on their desktop. And without having to say so much more, we went from 127 measures in the last project. In this new one, we had just 5 indicators. So let us talk a bit, and the reason I'm explaining this is to give you to understand how important it is for software industry to have a very close cooperation with academia. So, measurement program, what's that? Here we have the conceptual model. And one of the reasons we wrote this book was the limited information around this topic. What we lacked the most was the holistic view of what's included in a measurement program. We're talking about the roles, the structure, the usage, maintenance, evolution, and so on. So let us go through quickly what is a measurement program. So here you can see within the circle you have on a very high level the components that build up a measurement program. So let us start with the databases. The databases include information from parts of the data sources. And here you store information, just the information that is needed in a refined way. For instance, the dates, they are in the US or the European format. Then you have the experience databases where you store the information, the lessons learned from measuring. For instance, widgets are better than Excel, or the measurement process is not sufficient because it does not address sufficiently the needs of the customers, and so on and so forth. Information product is where the result of the measurement is presented, usually with additional information. And Miroslav showed you some examples. You have Excel files, PowerPoints, gadgets, widgets, dashboards, apps, emails, business intelligence tools, and so on and so forth. So measurement system is a system that collects information, processes information, and presents a result. And of course, information product is part of the measurement system, but here we have consciously put that outside it, since, for instance, how to present information is a discipline by itself. So here we keep just the technical parts of collecting information, processing that information, calculations, and then updating the information products. Measurement organization, as you can see, there are a number of roles involved in software measurement programs. And those roles that have an asterisk that are taken from the ISO IEEE 15939. Hopefully everybody sees this. But there are other roles as well, except for what's stated in the standard. For instance, you have database administrator, you have the data analyst, the measurement designer, the guys who write the code for the measurement systems, and so on. The last part of the measurement program is the measurement infrastructure. And it's the infrastructure that supports the fetching of the data processing, the data distribution, the data storage, and the monitoring. And we will come back to the monitoring. And of course, what's input and what's output? Very briefly, people, products, processes, guidelines create the very basis for measures which we collect. And what is the output of a measurement program? You can summarize it into three areas. Information needed to take decisions, insights, and early warnings. So, this is the juicy part of the presentation. Here you have what you have to have in place in order to know if you have a successful measurement program, or what you need in order to have a successful measurement program. So first, you need to have management commitment, simply because management has money. So no money, no honey. And also for instance, the management puts the ethical boundaries around measuring. Metrics team, if I take the metrics team that I lead, our mission is to provide insight into the performance of the products and the performance of the organization. And when I say performance of product, I mean both during development and when the products are used by customers. What I have experienced many years at many companies is the lack or the not seriously use of standards and theory. That's why I started with the example that I did to show you how important it is. If you want to succeed, you need to have standards in place. And with standards, they provide you, for instance, with a metrics language. So when you say stakeholder, everybody understands the notion of that. And everybody understands the difference between, say, indicator and measure. Automation, of course, needs to be in place because given the amount of data that we handle today, you cannot do it manually anymore. Also, if you want to succeed, you have to have very good structure. That's a very good spin-off of automation. And finally, every company, every organization has its own culture. And it's important that some of the measures used, especially the key performance indicators, reflect that culture of the company. So, Professor Staron and I, we have developed a tool that can, so we can measure, we can assess how robust the measurement program is. So you can apply this on whatever organization and go through. If you want to, we can send you the link after the presentation to this paper we have written. So, I would like to take a few minutes to discuss infrastructure because from my experience roaming around different companies, software companies, and or companies that use both software and hardware, I have seen not impressively use of the infrastructure. So there are a few things I would like to highlight here because this is key if you want to succeed. So one of the first things I would recommend is you need to decide which are my principles. which are the propositions I'm going to use that will guide me here. My team, we have chosen these three. Maintainability is extremely important because we don't want to put time on maintenance. So in order to do that, we have to have, of course, a very good structure, very solid, easy to use, and also since products, ways of working and software tools, they evolve constantly, I would say rapidly, we need to have such an infrastructure that can cope with that and evolve with the same pace. So at every company we have been, Miroslav and I, transparency has been a demand from management, from leading roles. They need to know how is the data flowing from data source to information product. And they need to know that nothing is happening with the data integrity. And I will talk a bit more about this. Stability, of course, is core to us, to my team, because if it's stable, then people can rely on this. And of course, we don't have to put time on fixing things. And of course, there are other things that you might want to focus. I mean, I'm not saying that this is what you have to have. I'm just describing what we have. You can choose to focus on efficiency or cost awareness, but we have to choose few. So the structure we have put up, and the structure we are helping other companies to put up, is on such a solid ground that it's easy to, I mean, we have developed over 40,000 systems after just what, 7 years, 6-7 years after the introduction of the metrics team at my company. And I'm talking only about my company. So, to exemplify, here you can see, or soon we'll see, an example of a server-based infrastructure. To the far left, you have the data sources. You have mechanisms that will extract the data and put it into the staging area of the infrastructure. And to the far right, you will have the information products. In this example that we have here, you see gadgets. In the measurement infrastructure, you can see that we have three main areas. The staging, where the data comes in, and the data is copied over to the raw data after checks that everything is okay. And then we build up what we call derived data tables, or views. Information placeholders, if you like, that live for a limited time, and each such data table is built up of one or more raw data tables. So the information products will access only raw data tables and or derived, but never staging. Self-healing provides robustness. Yes, that goes without saying. And it's necessary to have that, because when you handle those tremendous amounts, not only of data, but also measurement systems, you need to have some self-healing mechanisms in place, because that gives robustness, it saves time, and increases the trustworthiness of the infrastructure for the organization. Here you can see very briefly to the right, and such a mechanism that we built up years ago. It's based on Excel, as you may see. And to make it very simple, what we did here is that those that fail the measurement system, we just rerun it 2 or 3 times. By doing that, we saved 80% of maintenance. Quite cool. We have more complicated, but it's for another webinar. Okay. Another thing that I've been, so to say, within quotation marks, impressed by is how few, when I ask them, how do you know that you can trust what you see? There are so few people that can say, yes, I trust this because, and I ask them, can you prove it to me? And then I don't get any answer. Saying that we are a good programmer is not an answer. So Miroslav and I, we have developed different mechanisms to assess both the production of the information and also the consumption, so that we know that we can trust what we see. Let me just give you a brief example on the next page. So here we are using what is called the AIMQ framework, the quality attributes. I'm not going to go through them in detail, of course, but take into aspect the propositions of reputation. I mean, we all remember this. I'm not allowed to use bad words, but measuring how many lines of code the programmer develops per day. We all know what reputation this has. How do I know that the information is complete, understandable, and so on? So these are things that we need to take in place. And Miroslav and I developed also taking this even further when we talk about key performance indicators, how to assess that this information quality is in place and complete. So, back to the standard. I know it's many people find the standards to be boring, but to me it was a liberation to have this in place, because now I could say, okay, this is how the measurement system looks like. So, why not have probes, so to say, into every state and every transition, asking questions. Say, for instance, I'm measuring the defect backlog. So one of the questions I have to ask when I come to the base measure is, are you an integer? Because I cannot have 2.3 or minus 12 defects. And if an error is found, then I inform the stakeholder or the measurement user, so they know that. And to me, the metrics team, this means that 8 out of 10 times I know what the problem is. And half of the time I can fix this automatically. So for the stakeholder, it can be a red dot in a gadget. It can be a red cell in an Excel file, or in a dashboard. I can take away the information in the widget and just say error. It depends. There are different ways of doing this. And this, of course, the information quality has, of course, also to be automated. So when we check, we check the data flow, the data integrity throughout this environment. So the dotted area here, if you see to the bottom left, shows that we do some checks even in the data sources. Say, for instance, that we're looking at time. Every company, every software company measures how long time does it take to develop, in average, a feature. And every company has set up toll gates or milestones, so to say, to measure, to go from, say, milestone 1, 2, 3, 4. So what we check, just to give an example, is that the time is in order. So the last milestone cannot be older than the previous ones. What will happen then is that we discard this measure, the whole feature. We inform the stakeholders, you know, guys, this is wrong. So until you fix it, we will not take it into our measurement system. And over to you again.
Good. So now Wilhelm has introduced you to our infrastructure and how we use measures. And as you can see, this brings us to having huge amounts of high quality data that we can do something cool with. So as researchers, both Wilhelm and me, we're focusing on creating new things that could bring value to the company. We, instead of having new research engineers to do more metrics, we use machine learning to discover new metrics, find new indicators. We use deep learning to help the designers to draw conclusions from the data. And I'll show you a few examples of that. We look at this diagram is taken from a book. It's from the book by Alan and Brand, Software Metrology, and it complements the measurement information model from the ISO 15939 with the additional two areas, organizational and standardization. And we use those areas to help us to place different types of machine learning algorithms on that landscape. One of the areas is when we discover new patterns in the data, when we can crunch huge amounts of data from products in field and be able to predict if a particular product is about to break with few seconds or minutes warning. We can provide this early warning for the designers and operators to understand that something bad is going to happen and that they have so that they have time to actually prepare for that. We use machine learning to generate new decision criteria. So as the organization evolves and develops, we change the way the measurement system put colors on the KPIs so that the organization can constantly evolve and constantly be better without the human involvement. We also use machine learning to understand the standard model, to understand what is a normal way of working for a particular company. We could understand the number of defects or defect trends that companies have during the development and after development, and we could use algorithms that show that the defect inflows or other kind of parameters are outside of bounds. But the coolest thing that we could actually do with that is when it comes to actually learning from the organizations themselves. So the current studies that we do right now are the studies based on understanding code quality in a completely different way. Instead of measuring things like number of defects in the code or code complexity, we learn from the company's review system, Gerrit, how the company understands the code, how the designers reason about the code, how do they assess the quality, what kind of software constructs they react on when they review their code. We created this system called CC Flex based on that concept that we collect the data from Gerrit, which is this code review system for the companies. We understand which lines of code the designers have reacted upon, which they have complained about. We characterize them as a very large feature vector, and we provide that label of whether this line is actually good or a bad line, whether it violates, for instance, coding guideline or design rule. And we obtain a huge amount of data from 1,000 lines of code. We could get a lot of data and this a bit more semantic. And we use that data to feed that into deep learning algorithms that could learn different things from those parameters, that could learn, for example, how to write for. And we put that into convolutional networks, and we get the probabilities of how good or bad the code are. One could say that this is a very straightforward approach, but it requires a lot of experimentation and understanding in how this technology really works, how many input parameters we should have, how many layers, how many neurons per layer we should have, how many functions, what kind of functions we could use, how to provide this feature vector. And the coolest thing that we do with those networks is that we train these networks to understand different kind of concepts. So for instance, the very first layers, they understand the low-level patterns, like they recognize a non-standard syntax for a for clause in a C++, or an if clause, or they recognize the syntax whatsoever without having understanding the concept of a grammar in a programming language. And as we move through the network, we recognize even high-level patterns. For example, we use the code that cannot compile. We could understand the risk that people take. We could understand the concept of complexity. And based on that, we could draw conclusions related to probability. So it's a bit like human designers and human reviewers actually go through the code and try to analyze what is wrong with the code and how to fix that. So we can try to, the next step in our research is to, of course, try to understand how to fix those problems. The networks that we build are not necessarily huge, they're not necessarily complex, and you could see on the left-hand side how such a network looks like. This is a network that we use for coding violations that has been designed in Keras, which is a Google framework for deep learning. And on the right-hand side, you see that this network is quite good in recognizing violations and not violations. It's not perfect yet, because we need to understand a bit more how the structure works and understand the data quality, and this is still work in progress. But having those large amounts of data that we could have from companies provides us with this possibility to use this kind of novel techniques and give back to the companies. In this particular case, the value that we provide, the value that we give back, is the time the companies save to review the code manually. It's the time that the companies can save and focus on developing new features rather than constantly keeping quality of the code. That could be fully automated, and fully automated in a very arbitrary way. So to wrap up the seminar, we would like to say that what we think our success factors are is that we have this academic and industrial view on things. We have been working with each other for many years, and we've learned that this concept of having industry as a lab, action research, is crucial to keeping the measurement system, measurement program, and measurement systems novel and innovative. By doing this, we provide those new ideas to companies that could grab this, and we also learn from the company what works and what doesn't work. For the software industry, what we do is we provide insight into products and organizational performance by coming in as an external person, as an outsider. We are not bound. Researchers are not bound to the organizational structures and can move a bit more freely, coming up with new ways of measuring things. We also help the companies to rapidly adopt new technologies and learn both from us in academia, but also from other companies. The industry as a lab model, which we have, where we involve over 12 companies today, provides the companies with the ability to talk freely and openly under non-disclosure agreements to understand how they could improve and to transfer their best practices from one another without going through academia. And finally, for the success of the development measurement programs, as Wilhelm mentioned, we think that management commitment, metrics team, use of measurement theory, automation, and the measures that reflect culture and core essence of the company are the key. We have been very lucky to have had this management commitment from our colleagues, to have the metric team at the companies. We've been very lucky to contribute to some measurement standards and to be able to work with colleagues at different companies. So with that, we would like to thank you for listening.
Thank you.
We give the word back to Will.
Thank you, Will and Miroslav. That was a very impressive amount of work that you described, and the results were similarly impressive. I will encourage all the attendees to take advantage of this time to submit additional questions. We have a few. I'd like to start off by first asking you, 40,000 systems over 7 years. Could you describe the domain? Was there a product line? And yes, we'll just start there. Was it the automotive industry?
Sorry? What
kind of software systems were these?
Okay. We're talking telecommunication. This is I work at Ericsson. And also automotive industry. So it comprises measurement system about defects, both during development and from feedback from the field, requirement handling, time, different aspects, everything you can think of, even sometimes financial measurement systems.
Okay, there was over, once again, back to the 7 years that you have been applying the measurement systems. Have you seen any impact from introduction of new software development methods, for example, Agile versus Waterfall, and the evolution between those?
Oh, yes. That's a big yes. Absolutely. It's exactly as I said previously, that as ways of working change, so do measures. So we focus today highly on agile and lean measures. So we measure speed, for instance. That's very important. Cues, impediments in the flow of the code from, say, the desk of the programmer to the customer. We have cross-functional teams, for instance. So if you go back, say, 15 years, just to make an example, you had the management or project or line management decide what to be measured. Today, I have customers, so to say, from the highest management to the designers, the testers, individuals coming to the team and asking for help. So it's been a tremendous.
Excellent. So that sort of begs the question, the next question, is there a perceived return on investment? In other words, now that you've been able to amortize the cost of your measurement system infrastructure, there still must be a learning curve for the participants and management. Is there a perceived ROI, or how much does each new iteration cost?
Is my manager online? No, just a joke. Because he asked me also. No, I can give you, no, I don't have the number. What I can say is, since I've been measuring for so many years, because something that I love to do in almost every job that I have held, I see that the organization matures. For instance, 15 years ago, many people, many colleagues of mine were measuring the exactly same thing, but from their point of view, okay? They do not do that anymore because they understand the concept of the stakeholder. We have a metrics language, as I said before. We have less measures, but they're more in-depth. We have measures that are cascaded, so to say. They start on a high level, and then you drill down to find the source of, say, for instance, a problem. The maintenance takes less and less time. We have the possibility to do more advanced usage of the measures. For instance, we provide to our colleagues easy access to the raw data, or if they want to do filtering, advanced filtering, or whatever they need.
Good. Okay, the next question is, have you performed software measurement on open source software projects? In particular, can you identify which open source software projects?
Yeah, we do quite a lot of those comparisons. When we introduce new metrics, what we do is that we take software that has already been established, like we usually use Linux kernel, we take OpenSSL, we take OpenStack, products that are open source, but they are still very close to the quality of industrial proprietary software that has been used and in other places.
Next question, will it be possible to issue a formal quality certificate after qualification testing?
I'm sorry, what do you mean by qualification testing? Of measurement systems, or?
I believe they're referring to if you have enough confidence in the metrics that you gathered, that you would say that with some degree of certainty that assure the quality of a particular software system. And this is very speculative in future. Yes.
We have some measurement systems, although not at Ericsson, but at other automotive companies that try to support the designers when they collect metrics related to the ISO 26262 standard, which is about functional safety of software or other things.
Yeah.
But those metrics are not really used as part of the certification process. They are a bit certification process is a bit different in that. So
exactly. So we have, for instance, from the 25,000 ISO family, they recommend a number of measures, which we have, of course, but they're not far from sufficient to cover what we need. I mean, there is no standard that can cover everything. That's impossible. The need of every designer, every tester. Well,
here is a specific question dealing with security in particular. Do you have any metrics for measuring the effort in identifying and then remediating security vulnerabilities?
No, I don't think we have worked with that explicitly, right?
I would not dare to say yes. We work with it, yes, but as I see it, that is a discipline of itself. And what I do is that I ask colleagues of mine who work with the security to assess my infrastructure. Because I believe it has to be a different organization that does this.
Interesting. Next question. How would you get started with this system in a company that currently does not measure their software at all?
Yeah. Start with simple things. Do not buy tools, external tools. Use Excel, for instance. That works perfectly well. Use Task Scheduler so you can run the measurement systems automatically. Use what your organization recognizes. For instance, if you're measuring time or defects or test progress, start with that and start simply. Don't overdo it. It's unless you're NASA and sending something to the moon. Start simple.
And from our experiences, most companies who start with measurement systems, they usually start with measuring number of lines of code to get an understanding of how big the software is. They start to measure number of defects that are reported to get some understanding of the quality. They measure number of test cases passed and failed and executed to be able to track the progress of the testing and the quality assurance. So as Wilhelm said, start with small things and then evolve from there.
Yeah, start with few things. Don't start measuring everything, even if you can do it. I know it's tempting. I've done it, and it's one of my cardinal mistakes. Focus on few and take it from there.
I see. There is a follow-up question that asking if there are commercial software packages that provide a complete end-to-end software measurement solution.
Okay. There are many of those packages, but I don't think we use any of them because things out of the box are usually quite closed, so they don't really fit. You have to still understand how the measurement is done. And many of the measurement infrastructure that we do are based on the concept of using scripts or getting tools that we get hold of or company has to collect the data.
And as I presented with the infrastructure, in access to SQL Server, that's no strange thing, or if you use a non-SQL for that matter if you want to, or just a folder system. But when your manager or your tester, your colleague asks you, okay, how do I know that I can trust what you show me? What am I supposed to answer to that?
Good.
I can do it now because and it's simple. Believe it or not, it's simple to do it.
Well, then maybe there's a simple answer to this next question, but I think that there is a very many not simple answers. So the question is, what are the most important criteria against which we should evaluate the effectiveness of a measurement program?
Huh. That's a tricky one. It's so easy that it's difficult. So one example is, does the organization use less measures? Does the organization saves time? For instance, leaves the measuring to the metrics team and they just use the result. If the answer is no to those questions, then there you have it.
Okay. Okay, I wanted to, going through the list here, I'm sorry, just answering out some things in real time. Yes, there was an early question that said, are you going to provide references to your work? You alluded to a book, and I'm sorry I didn't see a reference to it in your paper, but would you care to provide guidance on where people should be looking for subsequent materials to address this area?
Yes, we can do that.
Yes, of course we can do that.
We can send it to you, Will, and if you can upload it somehow, would that be okay?
Okay, but you could just mention it now in passing.
Oh, okay, yeah, we have written a book. But
bring on the slide.
Yeah, you can bring on the slide. And of course you can Google, if you Google one of our names, you will find all the papers that we have written.
Yeah, so in the book that we've written, we collected our experiences and guidelines and checklists that one could use to get started with a measurement system.
And this is hands-on. If you're looking for deep metrology or heavy standard reading, forget it. This is hands-on. This is how you build your infrastructure. This is what you have to think of. Lots of questions, how to deploy it, how to evolve, how to maintain. So it's hands-on.
Okay, thank you. This question just in DevOps, are there ways of relating software development with software operations, and is there a possibility of a feedback loop?
Absolutely.
Absolutely, yes. In one of our research projects, we have looked at this feedback loop all the way from the field, so operation of software products in the field, to the designers who actually design in the new releases of the software. So definitely, and
yeah, I mean we had to do it. I mean, if you go from waterfall to fully agile, which we are today, you need to monitor this. So we've been doing for years now, because it's so imperative for us to be able to develop and verify our products very quickly. So if you are not measuring speed, please do. There is money to save.
Okay, this next question has to do with how do you validate your machine learning approach?
We use pretty standard metrics with Matthew's correlation coefficient, and we usually validate that towards the opinion of the senior designers or senior testers or senior architects that we work with.
Exactly. So they evaluate the results from the algorithms that we develop.
And in many cases, we also use active learning to support this learning process, both for the algorithms and for the organization or the designers or architects.
Okay. Thank you. And since we have time, there was an early question about self-healing measurement systems, and I was just wondering if you could perhaps go back and provide some more explanation or examples of some other examples of a self-healing management system that you've developed.
I mean, what do you mean by examples? How it works?
How it works, or how broad of a healing? What kind of errors? What does it heal?
Okay. So when we developed so many measurement systems, we started to experience a lot of problems with the stability of the infrastructure. There were, of course, measurement systems that were dependent on one another. They were dependent on the same databases. They were also updating themselves and so on. So one of the problems that popped up almost every morning when we came to work was that there were some measurement systems that did not execute correctly during the night. And every day it took up a few hours to go through those measurement systems, re-execute them, maybe restore to a previous version, and that would basically save 90% of our effort. So we came up with this idea of self-healing to take care of the most basic problems. For instance, re-execution of a measurement system. We could capture the problem when the measurement system crashed or didn't stop executing after a certain period of time, or the information quality was not good enough. And then the first thing was that the self-healing system would re-execute the measurement system a few times. And if that didn't help, then it would go back to a central storage and take a previous version of the measurement system that we knew was working, and then replace the old one, re-execute. And in most cases that would work. Yeah. So that saved those 90% of cases where this basically automatic care of it automatically, and only left 10% for the manual checkups.
Thank you. That was excellent clarification. I think that nailed the question perfectly. So with that said, I've run out of questions here, so I'm afraid we're just about out of time. Also, I'd like to thank Miroslaw and Will again for their informative presentation and insightful answers to the many questions. Special thanks to each of you for taking the time to attend and participate in today's webinar. This webinar was recorded. You're very welcome. This webinar was recorded and will be available online in a few days at http://www.6f.org, resources, webinar.html. You can find announcements of upcoming ACM and 6F webinars and other ACM activities at learning.acm.org and the 6F website, www.6f.org. So, on behalf of 6F, the speakers and myself, thanks again for joining us, and I hope you will join us again in the future. This concludes the webinar.